The capsule slams into Earth's atmosphere. Plasma burns outside the window. Parachutes deploy. The ocean rises fast beneath the crew. After years in space, they're finally home. Recovery teams rush the capsule. The hatch opens, and then something strange happens. The astronaut inside tries to stand, and Earth suddenly feels too heavy. Most people imagine the hardest part of a Mars mission is getting there. The launch. The 6 to 9 month journey through deep space. The landing on a hostile alien world. But according to many scientists studying human spaceflight, the most dangerous moment of the entire mission might come after it's over. When you return to Earth, because by that point, your body may no longer be built for this planet. To understand why, imagine the mission starting today. You strap into a spacecraft leaving Earth orbit. Within minutes, gravity disappears, and something subtle begins to happen inside your body. Not damage. Adaptation. Your body has evolved under one constant force, Earth's gravity. Every second of your life, gravity has been pulling on your bones, your muscles, your heart, even your blood. You don't notice it, but your body does. Gravity is the reason your skeleton stays dense. It's why your leg muscles stay strong. It's why your heart works hard enough to pump blood up to your brain. Remove that force, and the body begins to make adjustments. Astronauts on the International Space Station experience this constantly. In microgravity, bones no longer carry the weight they were designed for, so the body starts reducing them. Studies show astronauts can lose roughly 1 to 1.5% of bone density every month in space. That's similar to the bone loss seen in osteoporosis, except it's happening in otherwise healthy adults. Muscles follow the same pattern. Without gravity forcing your legs and back to work all day, the body slowly begins to scale them down. From the body's perspective, this makes sense. Why spend energy maintaining expensive structures if they're no longer needed? Space doesn't just weaken you, it convinces your body that Earth-level strength is unnecessary. But Mars is still months away, and there's another problem. Out here, there's no rescue. At its closest approach, Mars is about 55 million kilometers from Earth. At its farthest, it's more than 200 million kilometers away. That means communication delays can reach over 20 minutes each way. If something goes wrong, mission control can't help immediately. And the nearest hospital is a planet away. For most of the journey, the crew is completely on their own. Months pass. Eventually, the spacecraft arrives. After nearly a year in space, the crew descends through the thin Martian atmosphere. The landing is rough. Dust explodes across the surface. For the first time in human history, astronauts step onto Mars. And at first, it feels incredible. Walking is easy. You feel lighter, almost effortless. But that's because Mars' gravity is only 38% as strong as Earth's. If you weigh 100 pounds on Earth, you'd weigh just 38 pounds on Mars, which means something important. Your body still isn't experiencing the gravity it evolved for. Mars feels better than space. But it's not enough to fully restore the stress your bones and muscles were designed to handle. In other words, landing on Mars is not recovery. It's phase 2. And while gravity is weaker, other dangers remain. Mars has almost no global magnetic field. Its atmosphere is thin, which means astronauts on the surface are exposed to far more cosmic radiation than on Earth. Our planet's magnetic field and thick atmosphere block most of that radiation. Mars doesn't. Long missions there could significantly increase the risk of cancer and other health problems. NASA considers radiation one of the biggest challenges for deep space travel. But radiation isn't the only system changing, because something strange is happening inside the body. Without gravity pulling fluids downward, blood and other liquids shift upward toward the head. Astronauts often develop what's called a puffy face and bird legs appearance. Their faces swell slightly, while their legs become thinner. But the fluid shift can also affect the eyes and brain. Some astronauts develop a condition NASA calls Spaceflight-Associated Neuroocular Syndrome, or SANS. It can cause swelling around the optic nerve, changes to the retina, and vision problems. Again, the body is adapting to an environment it was never meant to live in. Months turn into more than a year. Eventually, the mission ends. The crew launches from Mars. They begin the long journey home. By now, their bodies have spent years in microgravity, and in Mars's partial gravity, their bones are lighter, their muscles are weaker, their cardiovascular system has adapted to pumping blood in a low-gravity environment. In space, blood naturally drifts upward toward the chest and head. The body interprets this as too much fluid, so it starts reducing blood volume. The heart also adjusts. Because without gravity fighting against circulation, the heart doesn't need to work as hard. Over time, it can actually shrink slightly, like any muscle that isn't being fully exercised. None of these changes are immediately fatal, but they all point in the same direction, away from Earth. Months later, the spacecraft finally reaches home. Earth grows larger in the window. Blue oceans, white clouds. The planet where every human body has evolved. Re-entry begins. The capsule slams into the atmosphere. Gravity starts returning. And suddenly, every system in the body must switch back. Blood must once again fight against full Earth gravity. The heart must pump harder. Bones must support full weight. Muscles must stabilize the body. Astronauts returning from long stays on the International Space Station often experience something called orthostatic intolerance. When they try to stand up, their blood pressure can drop suddenly. Some become dizzy, some faint. After only 6 months in orbit, many astronauts need weeks of rehabilitation to regain normal strength. A Mars mission would last years, which means when the hatch finally opens, the real test might begin. The astronaut tries to stand, but gravity feels different now, heavier, unforgiving. Because during the mission, the body wasn't just surviving space, it was slowly adapting to it. And adaptation comes with a cost. The longer humans live away from Earth's gravity, atmosphere, and magnetic protection, the more we drift away from the conditions that shaped us. Which leads to a strange realization. When we talk about going to Mars, we often frame it as a transportation problem. Build better rockets, travel farther, land safely. But the deeper challenge may be biological. Humans didn't just evolve on Earth. We evolved with Earth, with its gravity, with its atmosphere, with its magnetic shield protecting us from radiation. Those systems are so constant, we barely notice them, until we leave. Mars is one of the most reachable worlds in the solar system, but living there long-term would mean replacing pieces of Earth itself. Artificial gravity, radiation shielding, closed ecosystems, an entire planetary support system. Because the moment we leave Earth for long enough, we start learning something surprising. Earth isn't just the place humans live. It's part of the machinery that keeps us human, and the farther we travel from it, the harder it may become to come back.